Good morning. In the previous videos, I showed you some of the modern and state-of-the-art equipment and software that we have here at Duke. Today is going to be slightly different. We are going to talk about our slightly outdated wind tunnel balance. It's very heavy, bulky, it's not intended to be used with computer, and it's probably more than 30 years old. But it works, produces reasonably accurate results, and recently we made it work with our modern data acquisition system, so you can use it in your future experiments. Let's start with the basics. This is our balance. This is the load sensing part, and the unit that does the calculation and displays the results is this 6 display unit. So you need both of them in order to work with the balance. The balance measures loads at 6 degrees of freedom, so 3 forces and 3 moments. The positive definitions of each one of them is on these plates. In order to use the balance in your test, you gently slide it underneath your test section, the test section of the wind tunnel, and align your model with the airflow line. So it's a good idea to make this line parallel to the walls of the tunnel. When you are designing your model, you need to keep in mind that you need to interface to this plate through 4 of these holes. These are spaced 2 1/4 inch apart, and these are threaded at 1/4 20. So you can build something generic, something like this, that will just interface to this plate. Or you can build something that suits your model perfectly and very custom. One thing to keep in mind that you are not to remove this plate, because all the readings are calibrated to this face. One final word before we dive into operations. Whenever you are handling the balance, please do it through the external frame. These rods that you see throughout the balance, they are responsible for separation of the forces and for accurate measurements, and they are also very delicate. So please do not touch them, and try not to lift the balance through these rods. The display unit is connected to the balance through this plug, and this plug takes the readings to the data acquisition system. Let's talk next about how we actually operate the balance. So your model is in the wind tunnel, everything is connected to the balance, and the balance is connected to the display unit. First thing that you do is you turn on this unit, and you zero the values that you see. So the non-zero values are because of the movement of the balance. Each movement on the uneven floor will result in some reading in the load cells, and also maybe your model is slightly heavier or lighter than the previous one. So some unbalance is bound to happen, and it's totally normal. So you don't need to be precisely at 0, but it's a good idea to try to at least try. Now both of the plugs are plugged into the unit, and now we will connect it to the data acquisition. The wiring of the channels is single-ended, meaning that we have 1 ground and 6 high signals. So all the high signals are connected to the high portion of the channels. So the order goes like this. Lift is connected to channel 1 high, drag is connected to channel 2 high, side force is connected to channel 3 high, pitch moment connected to channel 4 high, yaw moment connected to channel 5 high, and roll moment connected to channel 6 high. And we have 1 ground. Now once the sensors are connected to the data acquisition system, It's just a matter of defining 6 channels inside. So, and we all know how to do it. If you need some help, go to my video that I did about the DAQami software. So one thing that will be different here is that we are going to define the channels as single-ended. Let's see how we are doing it. So this is, we're activating 6 channels. And of course you can connect the channels to other numbers. It's just the way that we did it here. Each one will be defined as single-ended. That's it. And we'll probably want to reduce the range. Let's say 5 volts is more than enough. Okay, so now in order to not get confused, we are going to name those. So this is drag. This is side force. This one is pitch moment. This is the yaw moment. And this one is the roll moment. So all of them are pretty much straightforward, except one thing. We found out that the units here, they are playing like an inconvenient trick. So let's say we are doing pounds, which are the forces. And for lift, the multiplier is 1.102.32. That's it. Now we are going to the drag. We are still selecting single-ended. We are still selecting 5 volts. But once we are getting to custom and putting pounds, this is hardwired for you. Now the balance has different scale factors for each one of the channels. And for some reason this software does not support this. So what we found, like workaround, is the following. We are just naming them differently. So this will be lift, pound lift. These are 102.32. This will be pound drag. This will be 106.95. Side force, single-ended, 5 volts, custom, and this will be pound side. And this is 98.39. Now we're getting to the moments. So this is still single-ended, still 5. But here we are doing feet pound, and this will be pitch. This is 54.24. Yo. By the way, you don't need to remember the numbers. I will put a link to the datasheet in the description of this video. This is yaw. Okay. I got confused here. So this is roll. So this is feet pound. This is roll. And we are changing this roll. And the multiplier here is 52.31. And this will be yaw, and still single-ended, still 5 volts, and this one will be 3 pound yaw, and for this is 91.59. That's it. Good idea to see if we are all consistent, and we are going to the display. Let's do some strip, and in one we are going to throw all the forces: lift, drag, and side force, and And let's see another one. We're putting pitch, row, and yaw side. Let's see if we're working. So everything works. I'm just playing with the potentiometers. Show you that everything is alive. And the same goes here. So yeah, this is how you use your load cell. Okay, several final comments about this balance. First, all the values that you measure, that you get out from this instrument, are calibrated to this surface. For example, if you are mounting something on top and you are looking at pitch moment, for example, pitch moment being this, that this moment is generated by everything that is mounted on top, and it is in the wind tunnel. So be aware of this when you separate parts and components. Next, in order for the balance to function properly, this pole or this mounting rod should be free of any support up until this panel. So no small holes in the floor of the wind tunnel for it to touch it accidentally. So it should not touch anything but this panel. And one final thing is these values. These values are just for reference. You don't report them. You don't make judgment with these values. So when you're using the correct scaling factor, these are your correct values. Yeah. So finally, take good care of this balance and use it wisely. Thank you.